Greetings everyone, we will continue our discussion on information retrieval systems. In the previous sessions, we have started the construction of inverted files and also various methods to construct these inverted files. So in the previous sessions, we have looked at how to construct inverted files by using your sorted arrays and also another method where you will not be using sorting technique. And in the last session, we have started how to construct your inverted file by using fast inversion algorithm. So we have looked at the introduction to fast inversion algorithm in the previous session. In this session, we will be looking about how the construction happens and what are the various phases in which the particular algorithm has to go to get your particular fast inversion algorithm inverted index. So as the fast inversion algorithm in the previous session I told you, so the input to the fast inversion algorithm is your document vector file where you will be having your set of documents and their concerning concepts. So each and every unique word present in your particular document will be treated as a concept and we will be having a set of concepts for each and every document. So as you have seen in the example, we will be having the first document will contain the concepts 3, 5, 12 and 14. The second document will contain the concepts 1, 3, 4, 11 and 12. So like this, the documents will be present along with its number concepts. So the concepts could be your unique words which you are trying to index in your particular index. So however, the document vector file is stored in a sorted order. So as you could see, the document vector file will be stored in sorted order according to the document, and inside the document they will be present as a sorted order according to their concepts. Okay, so this is how your document vector file will be present, which is what we have discussed in the previous session. In this session, we will be going for the construction process. So as I told you, your particular fast inversion algorithm will have to go through three phases. The first phase, preparation phase, where you will be constructing a set of tables. In the next, we will be performing the splitting of the document into various loads. And third, we will be having inversion. So we will be looking at all these three steps one by one. First step, as you could see, this is an outline of your fast inversion algorithm where you will be taking a document vector file. So this document vector file will be taking your as input to your particular inversion algorithm. So it will has to go through your preparation phase. As the preparation phase, we will be getting two tables. One will be calling it as the load table, another one will be calling it as the concept table. Okay, concept table. And the next, the particular document has to go through your splitting document. So what will happen is it will take the load table and it will perform the splitting of your particular document, and this particular document vector file and your concept file will be used in the third phase, that is inversion phase, to create your particular index. So the particular work has to be done by these three phases. What are the phases? First phase, the preparation phase, where we will be creating one load file and another concept file. Okay, concept postings file. So the load file will be used in the second phase of splitting the particular document into set of loads. And the third phase, where you will be using this particular splits along with the concept posting file to create your inverted file. So we will be going through these steps one by one. So the first step, that is the preparation phase. In the first phase, the entire document vector file can be read into two separate files. The two separate files will be calling them as the concept postings file. The second one, the load file. Okay, so what are this concept postings file and the load file? So this particular thing we have seen in the last session. We'll elaborate and we'll get a clear idea about this particular thing. So what is the thing? So this will be your document vector file which will be acting as an input. So first document, second document, third document, fourth document and 5 documents you are having as a part of your information retrieval system which are needed to be indexed. All these 5 documents will contain a set of concepts. So as you could see, document 1 will contain 3, 5, 12, 14 concept. Document 2 contains 1, 3, 4, 11, 12 concepts. 3 contains 2, 4, 5, 12 and 13. 4 contains 1, 5, 11, 12 and 14. Document 5 will contain 3, 7, 13 and 14. So these are some concepts which are present in your 5 documents. So remember that when you concerned about the third concept, which is present in the first document as well as the second document, those two concepts will be same. That is, the third document which is present here, the third document which is present here and the third document which is present there, or the third concept which is present there and the third concept which is present in the second document are same words. Okay, as you can understand, each and every concept number here, it represents one unique word in a text based document. That is, 3 will represent one word in a text based document, 5 will represent one word in a text based document. So this is your document vector file. So we will be reading this document vector file from the starting to the ending. Okay, and we will be finding out the number of concepts or unique concepts which are present as a part of these 5 documents. We can find out that we will be having at the max, the largest concept we are having is 14. Okay, the largest concept number we are having is 14, and we will be having a set of unique concepts. So these unique concepts are 1, 2, 3, 4, 5, 7, 11, 12, 13, 14. So we are having these 4 plus 3, 7, 10 concepts. So all these particular 5 document contains unique 10 concepts. Okay. So among these 10 concepts, we are going to break it down those 10 concepts into loads. Okay. So we have broken down these 10 concepts into 3 loads, load 1, load 2 and load 3. So the first one is the postings file, the second one is the load file. So we have to break it down into the loads, load 1, load 2, load 3. As I told you, these loads will be decided by the size of your primary memory. Okay, what will be the size of your primary memory and how much amount of data you can fit in that particular primary memory. So if you declare a one load, what will be the size of your particular load in such a manner that you should be able to fit in a primary memory. Okay, so if you create a load, you should be able to fit that particular load into the primary memory. According to the size of the primary memory, we will be deciding the number of loads here. So according to that, we have created 3 loads. So the first load contains the concepts 1, 2 and 1, 2, 3, 4. The second concept contains 5, 7, 11. The third concept contains 12, 13, 14. So the remaining things, what are these things? So the first concept, that is concept 1. Okay. So this is, as you are considering this as the first concept. Okay. As you are considering this as the first concept, remember this concept postings file will be used in the last, what you will call the inversion phase. Okay, this concept posting file you are basically creating so that you will be using this concept posting file in the inversion phase. So why you are mentioning this offset is you have to find out that what is the concept you are looking at. Okay, what will be the position of your particular concept. So the first one, you are looking at the concept 1. Concept 1, so since this is the first concept, I am making it as the offset as 0. Next, the concept 1 is present in 2 documents. As you can see, it is present in document 2, it is present in document 4. So we are mentioning the number of documents here. So now I can say that the concept 1 is present in 2 documents. Okay, so when you are trying to create an inversion file at the end, you can say that the first 2 elements will be concept 1. I think you remember while creating index, you will be placing your particular whatever words you are trying to identify in an alphabetical order. So in the similar manner, you are going to place your particular inverted file in an alphabetical order based upon your concepts. Okay, so you are going to create your inverted file from concept 1 to concept 14. So that is why first you have placed the concept 1. And you are going to create the number of documents in which it is present. So to create these 2 files, I have to go through this particular document vector once. Okay, I have to go through the document vector once to create this particular 2 files. So offset is 0. Why? Because it is the first concept you are looking at. So you are going to have 2 documents, that is your particular concept is present in 2 documents. When I go for the concept 2, I am writing the offset as 2 because so already you have filled the particular concept, that is the first 2 places of your inversion could be 2 places of your first concept. So the next 3rd place will be taken by your second document, that is you can take that as the first offset is 0, the second offset is 1. Okay, the first offset is 0, the second offset is 1. So the first offset contains the concept 1, the second, that is 1 offset, contains the concept 1, and your second offset, whatever the second offset, it will contain the concept 2. Okay, your second offset will contain the concept 2. So concept 2 is present at the second offset and it is present in only one document. If you check, it will be present in only one document, that is document 3. Okay, now if you go for the third concept, the third concept is present at the offset 3. Why? Because first 3 offsets are filled by 1 and 2 concept. So third offset will be present at third concept will be present at third offset, and it is present in 3 documents. So your offsets 4, 5 will be filled by the concept 3. Your offsets 4 and 5 will be filled by concepts 3. So this will be, so the 3 will be present in 3 documents, that is, it is present in document 1, document 5 and document 2. Next, if you go for the fourth concept, okay, it is present in 2 documents. So fourth concept will be present at offset 6. So since it is present in 2 documents, so your 7th one also will contain the 4th concept. So in the similar manner, okay, when you go for the load 2, you are having 5 is present in 3 documents, so your concept will start from 8. Your offset will start from 8. So next, your 7 will start from 11 and 11 will start from 12, 12 will start from 14, 13 will start from 18, 14 will start from 20. So like this, we will start from the concept 1 to all the unique concepts you have in the particular file, and you will be creating this particular based upon your loads. Okay, now if you go for the load table, you are having the 3 loads. What this load table basically tells is from which concept to which concept your particular load is present. I can say that the load 1 is present from the first concept to 4th concept. As you could see, the load 1 will be present from the first concept to 4th concept. So we are going to specify the number of concepts. So we are having 4 concepts, and then how many tuples you are having as a part of that particular load. As you could see, the number, it is present in 2, 3, 3 plus 3, 6 and 6 plus 2, 8. So we are having total number of 8 tuples which are part of the load 1. Okay, and if you go for the second load will start from 5th concept to 11th concept. Start from 5th concept to 11th concept, and it is present and it is having 3 concepts in the particular load, and it is having how many documents or how many tuples? 3 plus 1 plus 2, that is 6 tuples are present in load 2. In the similar manner, we will be having the load 3, where will be starting concept will be 12 and the ending concept will be 14, and you are going to have the number of concepts as 3 and the total number of tuples as 9. In this manner, we will be creating this particular 2 files, that is concepts file and the load file, which will be used for the next processes. Okay. So when you go for the next step, that is splitting step, so the load table indicates the range of concepts that should be processed for each primary load. So the first phase is just creating 2 tables. We have not broken down the particular thing into memory loads. We have just created 2 tables. And we have just mentioned what should be the loads. Okay, if there are any issues, we will be modifying the loads. Now, once after deciding on the loads, we have to split the data file, okay, whatever your particular data vector file, into a set of loads. So those loads will be decided by your load file. Okay, so the load file will tell what should be the set of concepts in load 1, what should be the set of concepts in load 2, what should be the set of concepts in load 3. So then we make a pass through the document vector file to find the input for each load. Okay, what you need to do? You should take this load file. Okay, then I have to find out what is the load 1, and then I have to find what will be the starting concept and ending concept, and I have to go through this particular document vector file to create the load 1. Okay, so that will be the splitting process. So then we have to make a pass through the document vector file, whatever you have seen in the previous step. So we have to take the document vector file, we have to make one pass from the starting to the ending, and create one load according to the load file. You have to create all the loads in the similar manner so that you can split the particular document vector file into set of memory loads. So the second step is about splitting these particular document vector file into memory loads. And the third step, whatever you have to do is, you have to take these memory loads, okay, whatever your memory loads you have created, use those memory loads and invert the file by using whatever the first step you have done, whatever the content posting file you have used. That content posting file will be used along with the splits to create your inversion file. So what you have to do as a part of inversion? When a load is to be processed, the approximate selection of the concept file is needed. While you are processing load 1, according to that one, the particular concept file has to be referred. Okay, while referring the concept file, you will be doing the inversion. So the concept file data allows the input to directly map to the output without any sort. So using the concept file, you can directly map your load into the output without any sorting. Okay, how you can do, I will show you. At the end of the input load, the newly constructed output is appended to the inverted file. So you will take the input and you will create one newly inverted file from the postings file as well as your load file. Okay, splits. So the final phase of processing involves inverting each part of the document vector load files using primary memory and appending the result to the inverted file. So what you have to do? So you have to take your whatever document vector load files, that is the splits. You have done the splitting and this particular thing is the split, that is the document vector load file is the one split. You have to take that particular split and it will be present in the primary memory and you have to perform the inversion and append the particular thing into a inverted file. So we'll take one load, perform the inversion and append it into a inverted file. You take the second load, perform the inversion and append it into the inverted file. Like this we will take all the loads and perform the inversion and store it in the inverted file. Like that we will be creating the complete inverted file by inverting the individual loads. Okay, the appropriate section of the concept file is used so that inversion is simple. Okay, we have to take the particular concept file which you have created in the first step and you will be using that particular step to create your inversion file. So how this will be done? So if you see the complete process, so the first step is the preparation step where you have created your load file and the postings file. Okay, you have created the load file and postings file. Next, you in the splitting process, you have taken the document vector file and you will be taking your load file. Okay, you will be taking your load file. So you will be taking these two files to create the splits. Okay, so what are those load files? So the load one and the document. So what will be the documents? So document 1 will contain the 3. So what you are basically creating here is, you have to take the load file and the first load file will contain concepts from 1 to 4. The first load file will contain concepts from 1 to 4. So we have to segregate what are the places in which the particular 1 to 4 concepts are present. So I have to refer all the documents. I will be referring all the documents. So in the first document, only the concept 3 is present. In the second document, we are having concept 1, concept 3 and concept 4. In the third document, we are having concept 2 and 5. In the fourth document, we are having concept 1. In the fifth document, we are having concept 3. Like this, we will create our memory splits. Okay, we will create our memory splits. We have to go through this thing, and for each load, I have to create my memory splits in this manner, like document and concepts. Okay. So in similar manner, we will be creating for load 2 and load 3. So this is the splittings file or load memory loads which you are creating. From these memory loads, you have to perform the inversion. In order to perform the inversion, we will be taking the loads. Okay. Then we will be referring our contents posting file and then we will be creating our inverted file. How we are going to create our inverted file? So first, I have to have the concepts. That is, we will take the first concept and in which documents the particular concept is present. Okay, we will take the first concept. So the first concept is present in two documents. The first concept is present in two documents. In which document it is present, we can refer here. Okay, we can refer in the load. So the first concept is present in document 2 and document 4. We are going to create the particular thing here. So in the similar manner, we are going to find out where is the second document and its position. And second concept and its position in the document. Third concept and the position in the document. As you could see, this is the complete inverted file. So the set of concepts and the position of those concepts in the documents. As you could remember, this is the index what we are trying to create. Okay, the set of words and the position of those words in the document. In the similar manner, here the words are represented by concepts. So the set of concepts one by one from 1 to 14. Okay, and the position of those concepts in each and every document. So in this manner, we will be creating your complete inverted file by using your fast inversion algorithm. As you could see, you are not creating or you are not using any sorting algorithm here. Okay, as you could remember, while you are creating your index by using sorting, you are wasting lot of time and memory. Okay, so but here you are not using any sorting algorithm to create your particular file. Just you are making a pass to the complete file to create your particular inverted index. So this is the fast inversion algorithm where you are trying to create your particular inverted index without using any sorting. By taking two conditions, that is, we are having a larger primary memory so that you can be able to insert your memory loads. Okay, and the inherent data whatever you are having is already in some sorted fashion. We are taking these two assumptions so that we will be getting a faster index. Okay, this is about your complete fast inversion algorithm. With a proper example, I think you can comprehend this thing. So the fast inversion algorithm is having the basic 3 steps. To summarize, the first step is your particular document vector file which we will be taking as input. We will be taking this particular document vector file as input, and you are going to create postings file and one load file. That will be the first step. In the second step, the second phase of processing uses your splitting process where you are going to take the load file and perform the splitting, and the third step we are going to take the particular postings file in the first step and your memory splits in the second step to form your inversion file, which will be the complete inverted file. So this is your particular fast inversion algorithm, and in the next session we will be looking for the next thing, that is not inverted files. We will be going for the next parts in your particular information retrieval systems. And we'll wrap up this session here. Thank you.